a very nice talk, the doctoral symposium, about formally verified human-robot interaction. But today she's talking about teaching to software engineering formal methods via collaborative learning. So Livia, please.
Yeah, thank you. You can hear me, right?
Yes.
Okay, thank you. Yeah, so today I'm going to discuss one of the experiences that I have with teaching during my PhD, specifically on formal methods to software engineering students through the application of collaborative learning. So the full title of the course is Formal Methods for Concurrent and Real-Time Systems, and full credits actually go to Professor San Pietro for coming up with the syllabus and the actual organization of the course. So the course is set in Politecnico di Milano, which is the university where I work. And it usually attracts every year about 40 students, although I checked it out and we're actually expecting a sort of popularity boost next year, as we have about 10 students more, which is promising. And it is offered to master science students in the computer science program, specifically advised for the software engineering track. But it is also a non-mandatory course for automation engineering students, although very few actually attended. So the high-level goal of the course is to, given the audience it is offered to, is to teach students how they can exploit formal methods in the software engineering development process or in the design of critical systems. So the structure also reflects this, as we try to balance the mathematical background, which is what usually terrifies students, and a hands-on approach, which is the side that I'm mostly involved in. So this is also reflected in the actual evaluation method of the course, as students can choose to either give an oral exam on all course topics or get 60% of the grade from a tool presentation of their choosing, and 40% from a group assignment activity, which is the activity that I'm in charge of, and also the main topic of the presentation. Unsurprisingly, the vast majority, so about 75%, actually choose the second alternative. So the main educational approach underlying the group assignment activity is collaborative learning, which, according to its definition, let's say, forces students to work in groups to solve together a problem or solving a task or creating a product. So as you can imagine, this also promotes a wide range of soft skills, as students have to work in groups, and each and every one of them has to put a little bit of effort towards solving the task. So this promotes responsibility, individual accountability, and clearly group dynamics emerge. So they need to work on their leadership skills and conflict management. On a more technical side, we have some educational goals envisaged for the assignment activity, as we try to push them to improve their modeling skills. So starting from informal requirements, an informal description of the model, of the system, they have to produce an actual formal model. They also have to work on their critical thinking and analytic skill, as they have to interpret the verification results to gain some value from it. They are also encouraged to work on their capability of expressing themselves clearly, which is a big point for them. And it is also actually a requirement for scientific literacy, so it's really important. And for each goal, the group assignment envisages a specific deliverable. So in the first case, so for the first goal, students have to produce the formal model of a complex system. The second case, they have to run verification experiments with such formal model and actually exploit the results of these experiments to gain insights into how the system behaves, and test different configurations to see how these impact the verification results. And finally, they have to hand in a written report in which they are encouraged to focus on the modeling choices and the critical choices that they had to do during their project, and the reasoning that led them to make such choice rather than choose the alternative ways. Some logistics. The group is carried out in teams of 2 to 4 people, and they usually have about 2 months to work on the project. It is fully developed using one tool, so they all use the same tool, Upal. Clearly, since most of them have never had any experience with the tool, I give them a presentation of the project content and a hands-on demo of UPAL before they start. So they have some reference before they start working. And they are also not lonely during the process, as they periodically refer to me to update me on their progress on the work. And I also give them feedback on how they can either improve their current solutions or help them tackle the issues that are currently stuck with. Just to give you a few details on what was the project theme from last year. So the students had to develop a formal model of a warehouse robotics management system. So they specifically had to create a network of timed automata featuring modeling the mobile robots, the pods, where the items stored in the warehouse were stored, the human operator at the edge of the system, and the actual delivery tasks that robots had to carry out. So once they have developed their automata network, they run model checking experiments of relevant properties about the system, specifically expressed in TCTL notation. And just to give you an example of the kind of properties that they verify, the mandatory one from last year was that it never happens that the number of tasks in the queue exceeds the maximum size, which means that the system is able to process tasks at a reasonable rate. So they had to play around with system configurations to check to analyze the model checking results. And finally, I also gave them the option to introduce stochastic features in the model and run statistical model checking instead of the exhaustive alternative, clearly for extra points. And apparently the extra point argument was convincing enough, as more than half of the teams actually chose to introduce the optional stochastic features. How did the students do in terms of evaluation? They actually did really well, which means that they were either very enthusiastic or I was too kind. We will never know. But they almost got the full score in average for all the deliverables. So 5 points out of 6 for the first one, full score for the second one, almost full score for the written report. So overall, the final average grade was 9.5 out of 10, which is really good. And there was no grade lower than 8.5. So this also shows that the results that came out were pretty uniform in terms of quality. So all the students did really well. On the other hand, how did we do? So Politecnico clearly, let's say, forced the students to fill an evaluation questionnaire at the end of each course that they attend. But the results of this evaluation are not made available until much later after the course is done. So I sent them let's say, a non-mandatory evaluation questionnaire, which had custom questions that specifically targeted the group assignment activity, which was filled by 65% of the class, which is not a huge number, but let's say a decent percentage to assess the situation. So to give you an overview of the main results that emerged from this questionnaire, the self-assessed confidence level on course topics before attending the course was clearly quite low, so 2 to 3 points out of 5. Fortunately, the self-assessed confidence level after attending the course, they stated that it had indeed increased, so the average was 4 points out of 5, which was a promising result. I also asked them what part they preferred about the course, and about 75% of the participants indeed stated that the project was their favorite part, which is not surprising, as usually students do enjoy putting the concepts that they learn during theoretical lectures into practice, so they usually enjoy hands-on activities. There was also a question about what kind of impact the group assignment had on their interest towards course topics, which is one of the most critical aspects about teaching formal methods. And fortunately, almost all of them said that working on the group assignment did indeed increase their interest in these topics. So the overall, let's say, satisfaction level was about 3.2 out of 4, which is a good score. Indeed, as I mentioned earlier, the official evaluation results were not available in July when I wrote the paper. They are available now. So the official, let's say, evaluation score for the course is 3.3, which is aligned pretty much with the results that we obtained in June. And it is also in line with the average satisfaction level for all Politecnico courses, which is about 3.2. So this means that students in average do enjoy our course as much as the other courses that they attend, which is a very promising result when it comes to formal methods teaching, which is usually not the students' favorite. Okay, thank you.
Thank you very much, Livia. We can take a few questions if you have them. It's really nice to see this kind of teaching. Claudia has a question, I see.
Yeah, really nice talk. Thank you for the contribution. My question is about if you are planning to teach this course again next year or in the future, and what do you think you want to improve compared to the current teaching? Maybe if you are want to change the content of the course, or if you want to do any change.
Yeah, so well, I hope they will have me for next year. So yes, I am planning on continuing on this teaching activity. And one thing that it was an idea that came up this year while we were planning, but we never it wasn't brought on in the end. So we would actually like to maybe extend the range of tools that the students can use for their group assignment activities. So instead of forcing them, let's say, to use UPAL, we may give them the option to also choose an alternative tools such as Prism. Clearly, maybe even run like comparative approaches to see how the two tools differ in terms of performance and capabilities, clearly for extra points. So we might want to investigate this option.
Okay, Juana has the next question.
Hi, thank you, Livia, for the talk. I'm very interested in the course you taught, very interesting with using UPAL. I had a question about the study you've taken, the evaluation. As you looked at the confidence levels, or more like the perceived confidence levels of the students in the topics, which of course at the beginning of the course, they would not be confident in the topics because they didn't learn them. And as expected, they have more confidence in them as they finish the course. So can you say something more about how did you measure these confidence levels?
Well,
like
okay,
the questions they asked them in the evaluation survey.
Yeah, so basically, okay, the scale was pretty much arbitrary. So I chose a scale from 0 to 5, which is the same that they have for the mandatory evaluation questionnaire. So it's the one they are familiar with, and clearly it is like a very hard. It's a hard variable to measure once, let's say, self-assessed confidence level on something. So there was actually an extra question that also allowed them to elaborate on the score that they gave. So the question stated, so if you feel that you have low confidence, what do you think is the reason behind it? Clearly, most of them stated that the mathematics behind the topics were the major obstacle that they faced. So this is how we allow them to elaborate on that.
Yeah, very good. Very nice. The follow-up question was very good idea. Thank you.